Hey guys, I hope you all are doing good. In the last lecture, we covered how to classify functions based on different types, right? So for example, we understood how to figure out whether a function is injective, surjective, total, or bijective, right? Now, it's very important to understand how do we figure out if a function is bijective or not in order to understand how we find the inverse of a function, right? So the basic idea is only if a function is bijective, then only we can find its inverse, right? Otherwise, its inverse is not possible. I'll try to explain why that's the case in this video, right? So let's start with the first definition of what is the inverse of a function. The inverse of a function essentially reverses the effect of a function. So if I have a function which goes from set A to set B, then its inverse, f inverse, this is the representation of the inverse, right? So we basically write f with a -1 symbol over it. So f inverse is basically going to be the opposite way around, right? F was from the set A to B, inverse is going to be from the set B to the set A, and it satisfies this condition. Now, if you take a look at this very carefully, if I do the inverse of the function, I get the value x again. Now, I'll try to explain it with a very simple example, right? Let's say I have these two sets over here, A, 1, 2, 3, and B, which is A, B, and C. So let's say I have this function which is from A to B, right? And this is the representation of it, right? So 1 points to A, 2 points to C, and 3 points to B. Now, if this is the function is from A to B, I know that f of 1 is going to be A, f of 2 is going to be C, and f of 3 is going to be B. Now, if I do the inverse of this function, right, first, what I need to figure out is whether the inverse is possible or not. Now, when is the inverse possible? Inverse is possible only when a function is bijective. Also, the domain of the f inverse is the range of the function. Let's try to understand what this means, right? What is the meaning of when a function is bijective, right? F is bijective if it is 1 total. What is the meaning of total in this case? Total means all the elements of the domain have an image, right? So let's check this condition over here. 1 has an image A, 2 has an image B, and 2 has an image C, and 3 has an image B. The basic point of total is every single element of the domain has an image, right? So I can say that this function over here is a total function, right? I'm just trying to revise how we declare whether it's total or not. Moving on, let's try to understand whether it's surjective. Surjective was the opposite. So if all the elements of the codomain have a pre-image, right? So if I take a look at it, the element A of the codomain has the pre-image 1, B has the pre-image 3, and C has the pre-image 2 over here, right? The basic summary I get is all the elements of the codomain have a pre-image. So that means this function is total and surjective. Now I need to check a final condition, which is I need to check whether this is injective or not, right? If all these three conditions are satisfied, then I can say that I can find the inverse of this function, right? Okay. Let's try to figure out whether it's injective or not. What is the meaning of injective? The basic idea of injective is all the elements of the codomain have a unique pre-image, I should say, right? So basic idea is they are pointed to by a unique element. Let's try to find out if that's the case, right? A is pointed to by a unique element 1, B is pointed to by a unique element 3, C is pointed to by a unique element 2, right? Each one of these elements is pointed to by a unique element, right? Which is from the set A. So I can say that this is going to be injective as well. Since all these three conditions have been satisfied, then I can say that inverse is possible. So let's try to understand what is going to be the inverse of this function, right? The inverse is going to be very simple. I looked at the function, I figured out that it is bijective in fact. inverse, I just replace, move the set B over here, set A to the right side, and I get A, B, C, 1, 2, 3. And now I just move the arrows to the other way around, right? So since in this side, the arrow was from 1 to A, in this the inverse of the function is going to be from A to 1. In this, it was 2 to C. In this, it's going to be from C to 2. And from 3 to B, so B to 3 in this case, right? So this is F, and this is going to be F inverse. So I hope that makes sense. Okay, so just a quick reminder once again. In order to find the inverse of a function, you need to figure out whether it is bijective. So you check all these three conditions, total, surjective, and injective. And then in order to find the inverse, you basically just switch the arrows. Now, this is easy to do when you have a very small set in this case, but we'll try to solve questions when we have bigger sets, right? So for example, when we are looking at sets of real numbers or integers, then those are complicated problems, right? But the basic idea remains same. So it's very important to understand the concept in this case, right? Now, let's try to also understand why do we need all these properties to be satisfied to find the inverse. Let's start with injective in this case, right? Now, injective basically means all these elements, right, should be pointed to by a unique element. Now, let me make a small change, right? Let's say this function is not injective. If it's not injective, then let's say 1 points to A and 2 points to A as well, right? And 3 points to C in this case. So let's try to understand what's happening, right? I say 1 and 2 points to A, 3 points to C, nothing else. B does not have a pre-image in this case. Okay. Now, try to think about what happens if I switch this function. So when I do the inverse of this arrow function, the resulting value that I get is A points to the two elements 1 and 2 as well, and C points to 3 in this case. C points to 3 is totally fine, but if you look at it, A points to 1 and 2 in this case. But if you remember the definition of a function, in a function, a single element of a domain can only point to a single element in the codomain, right? That's the most important property of a function, right? But if you think about it, when I had the function where the domain, two elements of the domain point to the single element, inversing it results in an incorrect function. So this is not a function, right? That is why I need this function to be injective in order for me to find the inverse of this function, right? Surjective and total are also important properties because in order for me, I need to have both the image and the pre-images of all the elements, right? Okay, so I hope that makes sense. Moving on, let's try to solve a few questions on the inverse of functions, and then we'll move on to composition of sum. Okay, before I move on to questions, I just wanted to cover how to find inverses, right? So I missed this topic. So let's try to understand how to find when we are given set-based functions and algebraic functions, right? Now, set-based functions is extremely easy to understand. So let's say if I'm given a function, example f equal, so if you remember, this is how like one of the representation of function looks like, 1 comma a, 2 comma b, and 3 comma c. Just for reference, I'll also draw an arrow diagram on this side as well, right? So what I'm trying to say is, one, two, three, A, B, C. So 1 to A, 2 to B, and 3 to C, right? Okay. Now, if this is the function, in order to find the inverse of this function, I simply have to reverse the elements inside the tuple, right? So I get f inverse equal a comma 1, b comma 2, and c comma 3. So I think this is going to be very easy to understand. But this is the one that's the more important one to understand, right? Now, let's say if I'm given a function f of x equal 2x plus 3. Now I'm going to be writing down a few steps, so you have to follow those steps and in order to figure out the final equation of the inverse, right? So I'm given the equation over here. First of all, what I'll do is step 1, replace f of x with y. So what I'm trying to do is replacing f of x with y gives me y equals 2x plus 3. Step 2, solve for x. So I get x equal, if I solve this equation, I get y minus 3 divided by 2, right? Finally, step 3, right? So I hope you understand all these steps. First, replace f of x with y. So I get y equal to x plus 3. Solve for x. So when I isolate x over here, I move this 3 to this side. Divided by 2, I get y minus 3 by 2. Finally, in step 3, replace y with x. This gives me, so the final equation that I get is f inverse x equal, sorry for the bad handwriting, but f inverse x equals x minus 3 divided by 2. So the final answer is, if f of x is 2x plus 3, f inverse x is going to be this equation over here, which is x minus 3 by 2. So in the basic idea, what you're trying to do is, you put this value y, you isolate this value x again, and then you get the inverse of the function, right? So this is how you basically find the inverse of a function. Okay, so I hope you guys have solved all these questions, right? So let's start with question number 1. Given the function f(x), x squared plus 1 with domain all real numbers. So domain all real numbers meaning from negative infinity to positive infinity, right? So does the function f(x) have an inverse or not? So this is a very good question to understand. Now, if you remember, what we covered is, in order for a function to have an inverse, it has to follow 3 different properties, right? It has to be total, surjective and injective, right? So now this is a tricky type of a question. In this type of a case, what I usually suggest is try to draw an arrow diagram for it, right? When you try to visualize the problem, it will be a lot more easier to understand what's happening, right? So what I'm going to do is, for this problem, let's say this is x and I'm going to draw the f of x over here, right? Now I'm going to consider 3 different values. So we will consider very simple values, -1, 0 and 1. And I'll try to find the answer or the f of x value for these 3 different values, right? So if you consider for -1, f of x is going to be -1 square plus 1, which is going to be 2. So I get 2 over here. So that means -1 has an arrow towards 2. If you solve for 0, I get 0 square plus 1, which is equal to 1. I get an arrow towards 1. Now everything is fine until this point, right? Each element is pointing to a unique value. But now when I try to find the f of x value for the value 1, I get that is also equal to 2. Now, if I ask you the question, is this a function or not? It is a function, right? Every single value is pointing to every single value from the domain is pointing to only one single value, right? So that's fine. -1 is pointing to 2, 1 is pointing to 2, 0 is pointing to 1. That's totally fine. Let's try to check the condition of injective. If you notice from these 2 arrows, from -1 to 1, the basic idea is that the negative elements and the positive elements would point to the same single element, right? Why? Because I'm basically doing the square of the value. So what happens when you do a square of a value, right? For example, if I do the square of -2 and 2, the answer will be same, right? So the square of -2 square equal to 2 square equals to 4, right? So it doesn't matter if it's a negative value or a positive value, their answer is going to result to the same fx value. Why is this a problem in our case? If you remember, if I inverse this function now, what happens is these arrows will point to, from 2 will go to -1 and 1. And according to the definition of a function itself, a value from the domain cannot point to multiple elements in the codomain, right? And that is why this is not going to be a function. So in summary, since this is not injective, that is why we can say that this is not going to have an inverse, right? So I hope you have a good understanding of how this works. So just a quick summary once again. You get a question like this, try to visualize it with an arrow diagram. It's going to make things a lot more easier to understand. Okay, moving on. Now the question says, if not, suggest a restriction to the domain so that the inverse exists. Now, again, this is a very good question. Now, what the question is trying to ask is, how can I make a sum change, or how can I reduce or increase the domain or make changes to it such that the inverse is possible? Now, if you think about the problem in our cases, if I consider all the negative and the positive values, they point to the same single value, right? So for example, -2 and 2 will point to the same value, right? Same way -3 and 3 will point to the same value. So what if I reduce one side of the set? Either I can remove all the negative elements or I can remove all the positive elements. So the change I can make is, I can make domain equal from the set of all from the negative infinity to 0, right? Basically, all elements from, so either they can be all the elements from negative infinity to 0, or they could be from 0 to positive infinity. What happens in this case is, now think about it, right? If I only ever have the positive values, so let's say I go from 0, 1, 2, 3, some basic 4 different real numbers. 0 is going to point to 1, 1 is going to point to 2, 2 will have the value 5, 3 have the value 10. What I'm trying to say is, if I consider only the positive numbers, each one of them is pointing to a unique value. All the elements in the codomain are being pointed to by a unique value, right? So this is total, this is surjective, and this is also injective in this case, right? And that is why I can say that the inverse of this function now exists, because I've reduced the domain from 0 to positive infinity, right? Okay. So I hope you were able to understand this question. This is a very important question to understand. Okay. Now moving on. Given, let f of x equal 2x minus 3 by 5, find the inverse. Very simple question to understand. Just follow the steps just like we covered, right? First, I solve for y. Y equals 2x minus 3 by 5, right? I'm going to try to isolate for x in this case. So I get 5y equals 2x minus 3, right? This gives me 5y plus 3 equals 2x. Finally, I get x equal 5y plus 3 by 2. So finally, I get f inverse of x equals 5x plus 3 by 2. I'll try to tell you what are the steps once again. I put in this as the value y equals 2x minus 3 by 5. Isolate for the value x, and when I isolate it, I get 5y plus 3 by 2. Now replace this y with the x value, right? So you get f inverse x equals 5x plus 3 by 2, right? So I hope you were able to understand this question. Moving on, let's try to solve question number 3. Now this is an important question once again to understand, right? Given the function f of x equals the square root of x minus 1, where the function goes from the domain, which is all real numbers, to the set of all real numbers, right? Okay. Find the domain of definition and the range of f. Let's try to understand these two definitions once again, right? Domain of definition basically means all the elements in the domain which have an image, right? And the range basically means all the elements of the codomain which have a pre-image, right? Now the question is asking, find the domain of definition and the range. Basically find all the elements which have an image and find a set of all the elements which have a pre-image. Now let's take a look at which elements are going to be in the domain of definition. I am given domain is equal to all real numbers, right? That's the very basic thing to understand. Try to take a look at this equation over here. This is the square root of x minus 1. What happens when a value is in a square root? Do you think it's possible to put a value, a negative value inside a square root? Can I put negative 1? That's going to be a complex number. So this is going to be undefined. What I'm trying to say is, when it comes to square roots, you cannot put negative values inside it. It could either be 0 to positive infinity, right? So what value can I put over here so that the value results in a positive or a 0, right? The basic answer is going to be the domain of definition is going to be from 1 to positive infinity. Why? Think about it, right? If I input 1 over here, I get 0. So this is a valid value. And if I put any positive value over here, right, greater than 1, it will also result in a positive value. This is possible, right? But think about it, right? If I put in a value which is less than 1, so let's say I put 0 in this case. This results in the square root of negative 1, but this is not possible, right? So what is going to be the domain of definition? It's simply going to be all the values from 1 to the positive infinity, because these are only the values which are going to have an image, right? If I input a negative value or a value less than 1, then it is going to be undefined. So that's the basic idea of the domain of definition, right? Now let's try to understand what is the range in this case. Range meaning, let's try to understand range once again, right? All the elements which have a pre-image. So what I'm trying to find is what are going to be the resulting values that I find. Try to think about it, right? Okay. This value can result in a 0. So if I input 1 minus 1, it results in a 0. Do you think it's possible that I input a value in the square root and it results in a negative value? It's not possible. So negative value not possible, right? But if I input any other value in the value of x over here, all those values should be possible, right? 0 is possible, and if I keep moving on, all those values until infinity should be possible. So x goes from 1, 2, 3, 4 till positive infinity. I can input all those values, and those should result in valid values in the codomain, right? That's what I'm trying to say. So my range in this case would be from 0 to positive infinity. Now I'll try to explain this with a, let's take a look at it with an arrow diagram, right? Let's say x, let's say f of x over here. Okay, first I need to figure out, so I'm given that minus 2, minus 1, 0, 1, 2, 3. This is the domain in this case, right? But what did we figure out? What is the domain of definition, right? Minus 2, there cannot be any arrow. Minus 1 cannot have any arrow. From 0, 0 also does not have any arrow because they result in a negative value, right? From 1, I start getting a value inside the range. So 1 results in a 0, 2 results in a 1, 3 results in a square root of 2. So if we take a look at this over here, my domain of definition starts from 1, goes to positive infinity, and my range starts from 0 and goes till positive infinity, right? And that's the answer, going from 0 to positive infinity, right? So I hope you were able to understand all these questions, right? Moving on, we also have to find the inverse of this function, right? Now again, y equals square root of x minus 1. Now, since this is a square root, I'll square both sides, right? So I get y square equals x minus 1, right? Okay. Now, I'm trying to isolate for x, so I get x equals y square plus 1. Now, if I do the inverse, I get f inverse x equals x square plus 1. So I hope you were able to solve this question. Now, in the next video, we will talk about the composition of a function, and then we'll also talk about the sum of functions, right? Okay, so I'll see you guys in the next video.